First thing I want to do in reviewing your homework is give you a list of what I want you to have on your graphic organizer for parallelogram. And all this stuff is in your book from sections, I believe it's 6.1 to 6.6. But just so I'm sure that we've all got the same stuff, we'll go through here and just make some little bullet points. Okay, so a parallelogram is what we're going to be dealing with today, and base word of this is parallel, and we get our first bullet point from that. Okay, our opposite sides of a parallelogram are, you guessed it, parallel. Okay, that means that these two lines are parallel and these two lines are parallel. If that's not the case, then it's not a parallelogram. It could be a quadrilateral. Okay, as long all of these are going to be quadrilaterals because they have four sides. Okay, but only a parallelogram if you have opposite sides parallel. We also have continuing on with the opposite theme. We have opposite sides are congruent. Okay, meaning that this side and this side are the same, have the same measure. This side and this side have the same measure. And again, in keeping with the opposite theme, we also have opposite sides. I'm sorry, not opposite sides, opposite angles are congruent, meaning that this angle is congruent to this angle, and this angle is congruent to that angle. All right, that kind of ends our opposite theme. That's all the opposites that we have here. Okay, so next we'll talk about consecutive angles. So to refer to these, I'll number them 1 through 4. So what I want to say about them here is that consecutive angles are supplementary, meaning that they add to give me 180 degrees. So that's going to be any two non-diagonal angles. Okay, so 1 and 2 would be consecutive and supplementary. 2 and 3 would be consecutive and supplementary. 3 and 4 would be consecutive and supplementary. 1 and 4 would be consecutive and supplementary. And so going in either direction, clockwise or counterclockwise. 2 and 4 would not be consecutive angles. Okay? These are opposite angles, so they're congruent, not supplementary. All right. Moving on to our diagonals. And diagonals go from one vertex to the other. So you've got the black and the blue diagonals here. And there's two things that we need to know about the diagonals of a parallelogram. The first thing is that diagonals bisect one another, meaning that these two line segments are congruent and these two line segments are also congruent. Okay, so this blue segment and this black segment are not necessarily congruent. All I know from the given information of being a parallelogram is that these two are congruent and these two are congruent. And then also with my diagonals, I know that when I draw the diagonals in, one at a time instead of both. Let me just erase everything here. When I draw them one diagonal at a time. I'm cutting this parallelogram into two congruent triangles. Okay, so triangle 1 here would be congruent to triangle 2. And we're not going to use this a whole lot right now, but it will come into play and some proofs and things on down the road. But let's go ahead and jot that down as a bullet point for one of our characteristics, that each diagonal creates two congruent triangles. Alright, so these are the things I want you to have as your characteristics for a parallelogram. And we'll go through each one of these throughout the course of the week and get this thing completely filled out and make sure that we've all got the same stuff. So go ahead and get your homework out from last night if you don't already have it out, and let's get ready to go over that. Alright, your assignment yesterday in class, and to finish this for homework if you didn't finish it in class, was page 407 2 through 6. So for number 2 here, and you can see your answers are out here, so if you want to kind of check those as we're going along. For number 2, it's understood, since this is a section on parallelograms, that everything that we've been given here is a parallelogram. So for number 2, you've got two options here. You can either use the fact that opposite angles are congruent, or you can use the fact that consecutive angles are supplementary. So there's two separate equations that could have been set up here to solve for x. You can either do 2x minus 1 equals 75, or we can do 2x minus 1 plus 105 is equal to 180. Okay? Either one of these would get you an answer of x is equal to 38. Number 3, you have 3 of the 4 sides given to you here, and the only 2 that matter are going to be these 2, because I know opposite sides are congruent, and this is the information that's going to allow me to set up an equation to solve for the variable, which is what I've been asked to do. Okay, so the right side here is congruent to the left, which means their measures are equal. You set up the equation there, and y has a value of 15. Number 4, here you have the pieces of the diagonals given to you. I know that the 2 blue segments are congruent and the 2 red segments are congruent. So I have an equation that I can set up here to solve for A. I've got A minus 7 is equal to 2. And then an equation that I can set up here to solve for B. 2b minus 2 is equal to 10. Okay? And then when we solve there, we get A is equal to 9 and B is equal to 8. Very similar for number 5. Actually, same process. The only difference here is that your equations are going to be a bit more complex. Okay, so you've got the blue segment congruent to this blue segment, the red segment congruent to the red segment. Set up your equations here. Since I know that diagonals bisect one another, I can say that 4w, that's not a 4, 4w minus 7 is equal to 2w plus 3. Solve that equation and you'll get a value of 5 for w. Your other equation to solve for b is going to be 2b plus 5 is equal to 3b plus 1. Solving there, we get a value of 4 for b. All right, moving on now to number 6. anytime I'm given a problem that has to do with coordinate geometry, and what coordinate geometry means is I'm dealing with something on the Cartesian coordinate plane here. I've got something on my x and y axis that's been graphed. And so I don't necessarily need to plot a at -4, 6. But I do know that -4, 6 is going to be in the second quadrant somewhere around in there. Okay, I know that B is going to be in the first quadrant over here somewhere. I know that C is going to be in quadrant 4 and that D is going to be in quadrant 3. So I don't necessarily need to draw myself a Cartesian coordinate plane and get my intervals all spaced out evenly and perfect and all that to really see what's going on. Okay, just kind of sketch yourself out an x and y axis and then put the points in the quadrants that they go in. Okay, you don't need it to be perfect to see what's going on. And then connect your points. And again, these lines are obviously not parallel. My opposite sides are not congruent. My opposite angles are not congruent. My consecutive angles are not supplementary because this is not drawn to scale. This is a rough sketch so I can get a general idea of what this figure looks like. Okay, this is my A, this is my B, this is my C, this is my D. Okay, so you can put some tick marks on here of what's supposed to be true, as according to what you need in reference to the question being asked. In this case, they're asking me for the coordinates of the intersection of the diagonals, so might as well go ahead and draw the diagonals in and kind of get a sense of what I'm looking at here. And I've got diagonal going from A to C and a diagonal going from B to D. And so we talked earlier about one of the characteristics of a parallelogram is that it splits my diagonal into two congruent segments going in both directions. And if I know that this is true, that this point splits AC into two congruent pieces, and it also splits BD into two congruent pieces, then I can say that that is the midpoint of, that this is the midpoint of A to C, or I can say that this is the midpoint of segment BD. So you kind of have your pick here. You can either do find the midpoint between A and C, or find the midpoint between B and D. Doesn't really matter. I'm going to use A and C here and find the midpoint between them. So this is going to be my x1, y1. This is going to be my x2, y2. And plugging into my midpoint formula, I have x1 plus x2 over 2, and then y1 plus y2 over 2. And so the midpoint between A and C is, this is going to be 0. 6 plus -2 is 4 over 2, reduces to 2. And if I would have found the midpoint between B and D, I would have gotten the same thing. Okay?